Hey guys, welcome to the Nerdvine. This is Pradeep Chaudhary, and this video is part of the Data Science Lifecycle series. In the previous videos, we had created a fast API, we had performed a bunch of root operation using various HTTP methods on a custom data structure that we created, a list kind of a data structure that we created. And also we had set up Postgres database using Docker engine on our like for testing upload operation using Postgres database on our local. So now before connecting to Postgres database to perform various CRUD operation using our fast API, would have to create the required tables and with the required columns in our database. So to form this or to do this detailed operation, we'll be using a tool called Alembic. So Alembic is a database schema migration tool. So using which we'll be creating various scheme like various tables and like in a particular schema in a database, and we'll be maintaining those. So now before deep diving into Alembic, let us understand like first, why do we need to use database migration, schema migration tool? So in an industry kind of setup, we generally maintain multiple environments like staging, perf, prod, dev, like disaster, whatever might be required. So to maintain the same schema in multiple databases, this Alembic database migration tool will be super useful. We can easily integrate it with CI/CD to on various branches, and we can use those to maintain different environments, database environments. It makes it super useful for the developers as well to set up the database environments in the local to run and debug their applications. And if like you might also need to perform some migrations to migrate from one database to another. Alembic becomes super handy in those scenarios as well. It's a easy to use Python friendly way to perform your SQL operations, and also you don't have to share credentials with your developers for performing the detailed operations. So like in a way, it also helps you keeping your database secure. So now, like little bit of theory about Alembic. So Alembic is a database schema migration tool, as we already discussed. So it uses SQL Alchemy database toolkit on its backend, and it provides functionality for upgrade and rollback. Depending on the revision ID, we'll be deep diving more into how this particular thing happens in a few minutes. So it's like instead of SQL statements, you can use a Python friendly way to perform your detailed operations. So now, how this particular Alembic works is, so if you need to create, modify a table or perform some detailed operation in a table, what you would do is you would create new revision for that particular operation. So that new revision will be attached with the revision ID, which will be maintained in the database where you are trying to perform the revision on. And the Alembic will look at the last available revision ID in the database, and it will compare that with all the rest of the revisions that it has to perform, and it will perform the SQL detailed operations on that. So basically, this is an overview of Alembic, and like theory about like why is it required and all those. So now let's go ahead and we'll create our database migration scripts, all the directory structure that is required, and all those. So let's go ahead and let's jump in. So let me open a terminal. Zoom in first. Yes. So now we'll go ahead and we'll create our directory in documents folder. So I'm using the documents directory. Feel free to use any directory that you want. So in this, we'll be creating a folder called database migrations where all our files with respect to this will be. So first let's create environment.yaml file, which we'll be using to create our virtual environment using conda. Apart from this, we of course we're needing a readme.md. So let's go ahead and let's create that as well. So now let me open this particular directory in VS Code. So let me go ahead, open folder, and go to documents, open this database migration directory that we just created. So in this database migration directory, okay, that's weird. Why am I not able to see anything? I'm in the correct one. Okay. Just okay, my bad. So I created this two folders and the documents directory itself. So delete it and recreate it in database migration. Sorry for that. So would cd into that directory first and would create those files again. So now let's go ahead and we can see those folders now. We'll open this now. Yeah. So now we have the environment.yaml and let's go ahead and let's specify all the dependencies we need for this environment. So first parameter that would specify is the name of the virtual environment that we're creating. So would name it database migrations and the channel we want to run it in. Would be running it in default for this use case. Feel free to use anything that's more relevant to you. So we'll be running it in default channel. Then we'll specify the dependencies that we need to be installed here. So we'll be using Python 3.7, so we'll specify that. Then we'll be using SQL Alchemy as Alembic uses it for in its backend. We'll be using that. Also, we will need to import like install psychopg2 along with specify the version. Then we'll specify the Alembic. So we'll use Alembic 1.4.2. So this is with respect to creating our like specifying all the dependencies for our environment and to create our environment. Let's get the heading first here. And to create our environment, we'll be using conda environment command. So the command is conda environment create-f environment.yaml, and we'll be running this command. So let's go ahead and run it on our terminal. So it will take a few seconds to, okay, it's invalid. Okay, the tag should be channel, so we'll just stop it here and would make it channels and sidecar G2 also it was through showing somewhere, I guess. What was it showing? Sidecar G2 seems correct. Okay, let's try to run it again. Okay, so there's some typo. Okay, it should be psychopg2. Sorry, typo. Please excuse. Yeah. Now let's run it again. Okay, now it's working fine. So let's wait for it to install the packages. So now it's done. Now we'll activate the environment. Yeah, so now our environment is ready. So now we'll create the directory structure that we require for our database migration script. So let's discuss the directory structure first, then we'll go ahead and create it. So the directory structure, like there are various, like there is no silver bullet and the way you need to create a directory structure here, but there are a few conventions that we can follow. So I would be following a particular convention. Uh, Feel free to tweak it. That suits you in a better way. So the like directory structure that we'll be following is the root directory as database migration. Then for each of the database that we might be having in our for our application would be maintaining the revision scripts uh, in like under those names. So if we have one of the databases as postgresDB, we'll have one directory postgresDB. If say we have some other database called sales data, we'll have one more folder called sales data, and so on. So after that, we might also have multiple schemas in each of the databases. So for each of the schemas that we would be having, would keep the revision scripts under the respective schemas. So this is the directory structure that we'll be following. Uh, Feel free if you have any questions on this convention, feel free to drop it in comments, send me an email. Now, like we can discuss more. And now let's go ahead and create the directory structure. So first step is we'll create the folder for our database that we have. So we have a database called postgresDB. So we'll be making the folder postgresDB. So now let's cd into that directory. Now, in this directory, we'll initialize our Alembic, uh, uh, initialize our Alembic init command. So that from here we can run out database migration upgrade scripts. So to do this, so we'll specify we'll use the Alembic init command uh, with the schema name as a package. So we'll be running this. So let's go ahead and run this Alembic init. So we'll be creating a schema in our database that we ran in our previous video using Docker engine. We'll create call it FastAPI MOC. So we'll be doing Alembic init FastAPI. So it created a bunch of files in that particular directory. So now let's see what all files have been created. So one of the files that was created is alembic.ini. So this particular see what is there in this particular file. So this basically has all the configuration that this database migration scripts will run on. So one of the configuration is SQLalchemy.url will be more like this right now points to this particular database connection string. We'll be modifying it to point to our local PostGres database connection database host with the correct connection string. Apart from that, like bunch of configuration for other things like logs, time format, and all those things. So we can would be overriding this SQL alchemy .url parameter and so on. So apart from this, we have we have versions folder. Here the actual revision script will go, and this environment.py that has how this particular database migration scripts will run. So this environment.py can also be used to modify the parameters or override the parameters specified in the alembic.ini. So we'll be using this environment.py to override the SQL alchemy.url parameter with the correct connection string of our Postgres database that we are running in local right now. So now let's go ahead and we'll create our first revision. So to create first revision, what we can do is we can run the Alembic revision command. So we'll pass one more parameter with um, -m command, and we'll specify the message. Whatever we are trying to do in this revision, we'll specify appropriate message for this. So now let's run this in our terminal. Alembic revision dash m, and we'll pass the message here. So we'll name the revision script create student data, and let's run it. So it says like it successfully created the create student data script with this revision ID. So let's go ahead. Let's see up what's that in our revision. So we can see our revision script here. Here we have a revision ID. So basically, like for every revision, Alembic provides a revision ID which it further uses to track like which all revision it has to make in a particular database when you run this revision script. So this will be unique for each of the revisions that we make. So now let's go ahead and we'll create our student data table. So to create our student data table, we'll import a couple of libraries. So we'll import SQL Alchemy, a column and string, and um, apart from that, we'll import one more package from SQL Alchemy, that is the sequence and the create sequence. And sequence. So it will be used to create a primary ID for our table. So we'll create like we'll maintain a student s underscore ID that will be our primary ID, and it will be auto implemented. So to do so, we'll be needing packages, create sequence and sequence of the SQL Alchemy schema package. So let's go ahead and we'll uh, write or upgrade a definition. So basically, every Alembic revision has two particular methods. One is the upgrade method, one is the downgrade method. So upgrade method will be run when you do Alembic upgrade, and similarly downgrade will be run when you do a downgrade. So generally, upgrade is like something we are updating the table, creating new table. Those kind of things will go into upgrade. Downgrade will be something like if we need to drop a table, or like if that particular upgrade command is not successful, then how do we revert it back? Those kind of queries are in or those kind of detailed statements are in downgrade method. So in the upgrade method, first we'll create a sequence. So this sequence will be used to create a primary ID or s underscore ID that would be our primary auto implement ID. So I would create a sequence using a create sequence method that we already imported, and we'll call this table underscore sid underscore sequence. So then our main create table method. So Alembic uses its own type, like own annotations for performing SQL queries, and those are very simple to use and very Python friendly. So I generally use the Alembic's annotations to perform my SQL queries, but it also supports SQL Alchemy queries. So if you prefer that, then you can use that as well. So would create this table. So the table name would be student data, and here would after that we'll define the columns. So first column will be our SID. So uh, it will be a auto increment column. We'll define it as integer, so we need to import that as well. So we'll import integer from SQL Alchemy. So about the indentation. So we'll make it nullable as false because we don't want our primary ID to be false, like primary ID to be null, and we'll give it a default value, and our default value would be uh, the next value in our sequence. So to do so, we'll do next val, and we'll pass the table sequence ID that we created in the previous statement. So I will pass that as the argument. That's ID underscore sequence. Then will how does it calculate the table sequence ID using regular expression class? So we'll pass that parameter, and this is with respect to the primary column that we have. Then we'll go ahead and we'll create the rest of our columns. So one of the columns that we would have is, sorry, missed a comma here. One of the columns would have, so we'll maintain the data structure that we had done for doing a CRUD operation on this kind of data structure. So we'll be maintaining that. So one of the column will be name column, will make it string, and it will also be nullable as false. So for this particular use case demo, would keep all of the columns as nullable as false, but depending on the use case, you might want to keep it as true as well. So second, next column would be degree. It would also be string, and again nullable as false. We'll create one more column and call it section, and it will also be string, nullable as false. And after that would pass in which schema we need to create this table. So we'll be creating this in the FastAPI demo schema that we'll be creating in the Postgres database that is already running. So that's it with our create table method. For our downgrade method, we'll do a drop table. So we'll drop the student data table, and we'll specify the schema as well. Sorry. Yeah. So this is our drop table statement in the downgrade. So before running our Alembic revision, we need to do one more step. So we're seeing in the Alembic.ini, we have a parameter sqlalchemy.url using it, which the Alembic revisions know in which database it has to connect to make those revisions. So like right now, it's not pointing to the database that we want to run our database migration on. So basically to point to the database running in our local so that we make the revisions there. Like there are a couple of ways that we can do it using. So one of the simplest ways is of course like we'll change the like connection parameter pointing to our local directly in the Alembic.ini. But again, using this method, you have to always change the SQL alchemy.url parameter whenever you want to change the database. So the this will again like not solve a problem completely when we want to maintain multiple instances of database using version control or something like that, using CI/CD or something like that. It won't again you have to make the changes to the script. So what we'll be doing is we'll be overriding this parameter in, using our environment.py. So we'll be storing our connection Postgres database connection string in an environment variable, either using secrets or using some shell script or HashiCorp Vault or whatever credential manager you would be using. You would set it as a environment variable and would be referring that. So to do that, we'll import the OS library to so that we can read the environment variable and set it correctly in the Alembic.ini. So to do so, we'll use the config.set main option. Sorry for so much typos today. sqlalchemy.url, and this is the parameter that we are overriding in the Alembic.ini, and like what variable will be replacing it with is like the variable that will be reading from the environment variable using OS.env on method. and will be reading the postgresDB um, environment variable. So this postgresDB environment variable can be set in multiple ways. So will when we integrate it with a CI/CD pipeline using either Git or something else, we'll be setting it as secrets or we'll be reading it from vault or something. So now that we have set it to SQL Alchemy.url in the Alembic.ini, we have to set it set the correct environment variable in our local as well, so that we can perform our Alembic revision. So for local revision, so we need to export the environment variable. We'll call it postgresDB as we have referred using that name in our environment.py, and we'll specify the connection parameter for our Postgres database running in local. So the format of connection parameter in Postgres databases, uh, PostgreSQL colon slash slash your username of your database, colon your password. So our password was my secret password for our database that we set in local. At rate the host of the database, Postgres database that your instance is running on, then the port it is running on, then the database that we want to connect. So this is the connection string that will be storing it as a PostgresDB environment variable. So let's go ahead and let's run this. And if you want to print it, so we can do Postgres echo PostgresDB, and we'll see our connection parameter. So now we have set our environment variable pointing to the correct Postgres database that we want. Now we'll go ahead and we'll do the actual Alembic upgrades. So to do Alembic upgrades, Alembic provides a method called Alembic upgrade, and um, like it doesn't it allows you to pass few parameters as well. So like one of the parameter is head, so it will do the upgrade for the latest to the latest revision that you have in your script right now. And if we want to just we don't want to make the actual upgrade, we just want to see this see the SQL queries of the upgrades that will be performed. We can pass it with dash SQL parameter, which helps you in testing the script first before actually running the migration. So let's go ahead and we'll run Alembic upgrade head dash SQL command to verify that our revision script that we wrote is correct, and there are no errors with it. So if we run this, it says cannot import name, create sequence. Okay, there is a typo in create sequence. Okay, sequence. Okay, that was bad. Okay, and yeah, so now we can see that this is the DDL command that the Alembic upgrade would be performing. Looks fine. So we'll go ahead and we'll do our actual upgrade. So to do our actual upgrade, we need to run the same Alembic upgrade command just without the dash SQL command. So now let's go ahead and we'll run this particular command. Okay, so there are a few errors. Okay, so before running this particular revision, we need to create our schema in the Postgres database that we create, that we ran in our previous videos. So to create the schema, so we are using DBWare as we set it up in the previous video. You can use any database visualizer tool that you might want to use. There are a lot of tools available in the market, so feel free to choose any of it. So we'll go ahead and we'll create our schema, FastAPI demo, and okay. So we can see our schema being created here. Now we'll go ahead and we'll run our Alembic upgrade head command again. So now it says it ran the upgrade successfully. So now let's go ahead and let's see our first API demo schema if the table is visible or not. So we can see our student data table here. If we go ahead and we do a view data, we can see the columns here as underscore ID, name, degree, and section. So like if you want to view further details about the schema, we can like do a DDL of it and we'll get the query that it is running to create this, like create the table. So all looks fine. So apart from this, one more thing that we need to like understand is how Alembic actually maintains the revision in the database that it is running the revision on right now. So what Alembic does is it creates a table in the public schema named Alembic underscore version. So in this Alembic underscore version, what it does is it maintains the last revision done in this particular database under a column version underscore now. So it like now we have one revision and the revision name like ID is this. When you make a second revision and run the revision on the same database, this particular version underscore now will be updated to the next revision ID. So next time when you run Alembic revision for the next revision, what Alembic will do is it will see what is the last available version underscore num in the public schema in Alembic underscore version table. And based on that particular revision ID, it will decide what are the revisions it has to move in that particular database. So this is how Alembic maintains the revision ID in the database. So now, we successfully created our table. If you wish to downgrade it because of some error or something, you can use upgrade down like Alembic downgrade head command using -1 to downgrade to the like uh, last revision, -2 to downgrade to two revisions before that, and so on. So this is it with respect to Alembic and Alembic revisions. We'll be using it like in the further videos in a much better way, like doing much more meaningful stuff. But for this demo, this is it. In the next videos, we'll be using our fast API to connect to this database that we just like connect to this table that we just created, perform output operation on this particular database. So that's it for this video. Have a good day, guys. If you like this video, do share, like, share with your colleagues, friends, and have a good day. Thanks, guys.